and the itself. Okay, the number itself. For example, I can say 7 are the prime numbers. Why? Because often you're saying no, we can say it has the two factors, 1 and 7 only. We can say that. Yeah. Huh? Yeah, of course we can take. We can 2 3. We can say 1 3, right? We can say 11 1 11, right? These are the numbers, are the prime numbers, right? These are numbers, prime numbers. Or somebody writes in this way: 2 into 3 into 5 into 7. If somebody writes in this way, whatever the number you'll get, I don't care. The number you'll get some number after multiplying all this one. When prime numbers, prime numbers, prime numbers, prime numbers. When the prime numbers written in the form of the multiplication, or we can say in the form of the product, okay, this is called prime factorization. I hope you understood that. This is called what? Prime factorization. What do you call this one? You call this one, sir, prime factorization. Why? Because the prime numbers written in the form of the multiplication, right? Wrong? These are written in the form of the multiplication. That's why we can say this is written in the form of multiplication. Prime number, prime number, prime number, prime number. So that's why it is called prime factorization. After multiplying this one, you will get a number. You will get a number. For example, let me tell you what I'm saying now. 2 multiply 3, multiply 3, multiply 4, 7, multiply 5, multiply 5. For example, after multiplying this number, you will get something. Okay, you'll get something. You'll get a number here. I just took a number. I don't know what number is that. Okay, after multiplying, you'll get a number. And I broke this number into the form of prime factorization, right? What do you get, by the way? Multiply, everybody. Huh? 4 5? 450. Okay, 450. It means 450 can be written in the form of the prime numbers in case of multiplication, right? That's why we can say that. That's why we can say what we can say, sir. This is called prime factorization. What, it doesn't matter that how many times 2 comes, how many times 3 comes. It does not matter, right? It does not matter that how many times 2 comes, how many times 3 comes. It does not matter that, right? 3 can become or can be there 2 times, 3 times, 10 times, 9 times, doesn't matter, right? Right, no? So we can say that 2 into 3 raised power 2 and 5 raised power 2. So we can do this form can be written in this way. So we can say that now 2 is a prime number, 3 is a prime number, 5 is a prime number, written in the form of the multiplication. That's why we can say all this. We can say that in this form or this structure or this image or this photo is called prime factorization. I hope you understood that. It's very clear. One more time. Let me tell you. So this picture is called prime factorization. Why it is called prime factorization? Because this is a definition of the prime factorization when the prime numbers are written in the form of the multiplication, right? That's what this is called, this structure, or we can say this form, or we can say this image, or we can say this photo, right? This kind of structure is called prime factorization. Question. Yeah. I'm sorry. This is called 100%. If I write to multiply, the power is same. Then we have to multiply the basis. To multiply 15 raised by 2. I'm sorry? To multiply. To multiply? 15 raised by 2. Oh, what great question you're asking that. He's asking a great question actually. He's saying that, so can I, no, when I have written this one and I call this one prime factorization, can I call this one prime factorization? Of course not. Because in this time what I did, we just made a pair here. With a made a pair of 3 and 5. We made the pair 3 and 5. We made the pair 3 and 5. And we made 15. And 15 is not a prime number. What I'm saying to you, for the prime number must be there. What you did, you have written. And now you can say that, sir, 15 can be written 2 times. 15 into 15. 15 is saying itself, I can be broken down. Or I can be written in some other way in the form of the prime numbers. Why you are just keeping me as a composite number? If you are keeping me as a composite number, then I cannot call, or this structure cannot be called as prime factorization. Do you feel what I'm saying now? So here 15 is not a prime number. 15 is a composite number, right? So we cannot say it is a prime number. It is a prime factorization. We cannot say that. Absolutely not. What we did, we just made a pair here. But this time we did not made a pair. What we did, we just broke. We just written power. Just we added the power. We did not write. We did not made the pair. What we did, you have done this one. Actually, what you did, 3 5 15, 3 5 15, and you have written 15 squared, right? And 15 is not a prime number. It's a composite number. So we cannot say this is called a prime factorization. We cannot say that. Because why? Because 15 is not a prime number. It is a composite number. You understood that? Puria is the first question. Now, what I'm telling now, the question we have, what is this? Find the.
Find the square root of the following number by using the method of factorization.
I'm gonna do the one question. You'll do the all the questions, right? Let me solve. Let me solve. Exercise three. Huh? You'll try by yourself. Let me do the first question. Try the hard question by yourself. Get that point? I, you know what? Why I'm forcing you? Because first number question, anyone can solve that. Anyone can solve. Even a class 3 student can solve that. So force yourself. Don't need to. You know what? What we do. We are forcing to the teachers or the one who is standing here. You are forcing to them. So solve the most hard question in the class, and we will solve the most simplest question in the class. Actually, you're forcing me to speak in the 9 o'clock in the morning time.
225.
Now, solution given numbers. We have the number here. You get that point? Now, what we have to do, we have to break into the prime factorization. Now, we will say that given number is this. Okay, get that point? Now, we need to find out the square root. What do we need to find out? Question is saying the square root, no? Square root, no? So, bhai, when the question is saying the square root, it means we have to put the square root. When the question is saying the square root, no? We need to put the square root there, right? When the question is saying the square root, we have to put the square root there. This is the given number, and the question is saying the find out the square root. We have to put the square root there, and using what? So write down prime factorization, no problem. You tell me. We got 3. Huh? 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 Nonsense. You tell me. 5. So here we can say that 3 into 3 into 5 into 5. Now, in case of the square root, from the square root, from the radical sign, the two numbers are same, but we take out. Two of the same numbers we take out one of the number. Two of the same numbers we take out one of the number, right, Rob? So here we can say 3 and 3 will be taken out, and 5 and the 5 will be taken out. So here we can say 15. So what we can say, hence square root of 2 to 5 is equal to 15. I hope you understood that. You have only 10 seconds to copy this one. 10 seconds. 1, 2, 5, 10. Closed. Next question. Put your hand there. Deliberately, I have done that. I addressed the board because you understood the thing. No need to copy. You will solve the question. This question by yourself. Interestingly, I have done that. I'm sorry for that. Let's go. Next question. 13.
Find the smallest number by which must be multiplied to get a perfect square. Also find the square root of the factors of
Everybody put your hand there for the 10 seconds. Don't you remove your hand, don't remove your mind and your eyes. Put your hand there in the question. 10 seconds. Don't speak anything. 1, 2, 3. Read out the question. Amar, when I said to read out the question, don't put your eyes here and there. 1, 2, 3, 4, 5, 6, 7. Put your hand there. Put your hand there. Put your hand there. It's over. Now the question is saying that by what number should we multiply this number, right? It means this number is not a perfect square number. First of all, now you can just directly, because this number ending with 2 and or any number ending with 2, that cannot be a directly. No need to check this down, right? Now let me just take the simple example here. First of all, let me ask you a simple question. Let me ask you a simple question. Let me ask you a simple question. For example, I have 50. Okay. Okay. Now somebody tells you that by what number it should be multiplied. It should be to get a perfect square number, right? Question is saying that by what number it should be multiplied to get a. So I don't know what number should be multiplied. Look at the board. Look at the board. अरे भाई साहब इतना सा बर्दाश्त नहीं कर पा रहे हो. I just watched you. You were looking down, and you are telling me that I was watching the board. What kind of nonsense is that? I'm watching you. I'm watching you, but you're not watching me. That's the problem. Look at the board.
So doesn't look at the board, not watch me, not watch me.
Huh, so look at the board.
Yeah, I'm looking at the board. Only 50 are focused.
So in this time now, the 50 is the number that question is saying that by what number it should be multiplied to get a perfect square number, right? I don't know by what number it should be multiplied, right? We will say, so first of all, we have to just break it down. We will say, we can just write the 2 into 5 into 5, right? Now in this time, you can say that 5 has the pair, 5 has the, isn't it pair of the 2 here? Don't follow the hand like this. You'll say 5 has the pair, 2 pairs here, the 5 of the 5 here, but there's no pair of the 2, right? What the perfect square says that whatever the prime numbers are there, they must have pair of numbers, a pair of we can say pair of pair of numbers. We can say that 5 has the pair. When do I say that something is a perfect square number? When all the perfect square numbers are those numbers which have the equal pair of factors. But you have studied that. Perfect square numbers are those numbers which have the equal pair of factors. Now, the 5 and the 5 has the factors here, 5 and the 5, 2 times there, but there's no factor of the 2. It means I need to tag 2 one more time. I need to tag 2 one more time. I need to bring the 2 here. I need to bring the 2 here to make a perfect square number, right? Whatever the work we do in the RHS, same work we have to do in the LHS. Whatever the work we do in the RHS, same work we have to do in the LHS. Because you cannot say that 50 equal to 2 into 5 into 5 into 2. Can you say that? I'm sorry? What did you say? What I'm saying now, what we are talking about now, I'm just telling you now, we are just telling, or we are just discussing here, what about the work we do in the RHS, same thing what we have to do in the LHS, right? So in this time, we can say that, so there's no pair of the 2 here, because perfect square, when do we say perfect square? 25 is a perfect square. Why? Because 5 and the 5 has the 2 pairs. You can see that. It is in pair. It is in pair. For example, let me just write 2 into 5 into 5 into 5 into 7 into 7 into 7 into 7. Now let's put your eyes there in this question. Whatever the product you will get, I don't know what the number you will get. That put your eyes there in this number. Just you tell me, after multiplying all this number, all these factors, can you get a perfect square number? No. Absolutely not. Sir, you can see there. So you just what we studied together. We studied together. So 2 has no any pair, and 5 has the pair, but this 5 has no any pair. And this 7 has the pair, this 7 has the pair. Of course, it could be the prime perfect square number, but right now it cannot be because 2 has no any pair. This 5 has no any pair. When this no any pair, so whatever the number you will get that, I don't know what number you will get. The big number you will get that. Okay, big number you will get after multiplying all these factors. Okay, all these prime factors, so you will get a big number. But that number cannot be a prime, cannot be a perfect square number, right? Bro? Why is so? Because this time you can see that there's only pair of the 2 here. So in this time also you can say the 2 5 into 5. The 5 has the pair here, but 2 has no only pair here. Do you feel what I'm saying now? So that's why we can say that. So that's why we have to make it a perfect square number. To make it, we have to tag the 2 one more time. And what about the work we do? And the question is talking about the smallest value. Because somebody can write here 2 and 2. Again, 2 times you can write that. But the question is saying that, of course, somebody can do that, no problem. And I'll multiply the 2 times here one more time, no problem. You get what I'm saying now? So now here, this has the pair, this has the pair, this has the pair. So whatever the number you will, after multiplying all these numbers, all the factors, whatever the number will come out, that will be the perfect square number. But the question is saying no, smallest value. What is saying? We have to try the smallest value. So how many times you will try 2? You will try 1 time. I hope you understood that. Let's come back to the question. Now put your hand there. Now, in this question, there's a number is given there. What is the number is given? A 30 number, no? Solution. Given number. 252. Right? Is it right? This is number. Okay. Should I solve this question or you can solve by yourself? We discussed it here. Chal, 2 1 ja, 2 ja, 2 6 ja. It's right? You tell me? Huh? 3. Okay, you tell me? 3, 2 1. Tell me. So guys, what we can write here, 2 multiply 2 multiply 3 multiply 3 multiply 7. Now you can see there, 2 has the pair here, 3 has the pair here. First of all, we have to write here, it is not a perfect square. I have written here P, you will write it. We just got the thing, it is not a perfect square number. It is not a perfect square number, right? 252 is not a perfect square number. So to make it perfect square number, what will you do? First of all, just write like this way, like a child. So 252 equal to 2 multiply 2 multiply 3 multiply 3 multiply 7. Now this is helping us, this prime factorization helping us. What should be multiplied? Actually, we have the problem with the numbers, not the prime factorization. What we have the problem? Which number we have the problem? Yeah, we are dealing with the numbers, right? We are not dealing with the prime factorization, right? What we are dealing? But this prime factorization helping us. What should be done with this number? By what number should be multiplied with this number, right? Okay, now you tell me to make the perfect square number. Actually, we have to write a lot of theoretical part, and 252 is not a perfect square number. To change the perfect square number, so we have to just make the equal pair of factors. We have to write all the bullshit things, but right now we are doing directly, okay? When the examination hall, you write everything in the proper way, okay? So now 2 into 2 into 3 into 3 into 7, but there's no pair of the 7 here. That's why you have to write with a different pen, okay? You have to write with the different pen. You use a different pen that is symboling, or that is symbolized here, that something another has been done here. Another thing has been done here. You getting my promise now? Another thing has been done here, right? So now you tell me, but what will you do? Multiply with the 7? Tell me now, yaar. Okay, now the hands will just rise us. So we can multiply this number quickly. Huh? Huh? 1764. Are you sure? Multiply. Everybody. Are you sure? So we can say that now, sir. 1764. Now the question was saying that what the given number, by what number given number should be multiplied to get a perfect square number. So guys, you tell me, by what number
7.
it should be multiplied, or we can say the given number should be multiplied with the 7 to become to get a perfect square number. Yeah, to be a perfect square number. So now it became a perfect square number. Now the question is saying that also so the whatever the number, so obtained means like the number talking about whatever the number you will obtain, or the number you will get, that talking about this number, okay? So we got the number here, 1764. Get my point? So now in this time we will say that, sir, we need to find out the 1764. We need to find out the square root of 1764. Okay, you tell me directly, you can just, what is the square root of 2 multiply 2 multiply 3 multiply 3 multiply 7 multiply 7, right? 42 square now, sorry, 42, yeah. So now you will say, sir, this can be written in this form. Not here, yeah, actually this will be written in this form, na yaar. That this thing I got from this, na yaar, and this equal to this. So it means this can be written this. So take out 2 from there, take out 3 from there, take out 7 from there. You tell me. 42. And now it is and now the question was saying that now question was saying the two things. By what number should we multiply? We will say that it should be multiplied. And when I the word saying that it should be, in talking about the given number. When I'm talking about the it should be, it means talking about the given number. Did you sleep in the yesterday night? Did you sleep in the yesterday night? Huh? But don't do that in the class. When the word is saying that, when the word is saying that, when the word I'm saying it means talking about the given number. What am I talking about?
Given number.
Given number. Getting a point what I'm saying now?
Yes, sir.
So I can say, you tell me, it should be, it should be multiplied by 7. Also, we can say that the given number should be multiplied by 7 to get a perfect square number. No need to write that. It is understandable because in the explanation, in the process, already it has been understanding. I'm sorry. What is that? It should be multiplied by 7. No need to write the 2 get a perfect square number. We got that. 252 should be multiplied by 7. You will get the 764. And 764 is a perfect square number. And the question was saying to find out the square root of the 764. Also, the question was saying that. So we have done here. What we get here? The question was saying to find out the square root. Square root, na yaar. The second part of the question, find the also square root. So just you tell me what will be the second line. We should write here square root of obtained number. Square root of obtained number, right? What's the meaning of the obtained number? So you tell me what we got here. This is the explanation to this type of question, to this kind of questions. Okay, you have only 30 seconds to copy to this board. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Time over. Stop writing. Ten seconds more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, stop it. You can move. Let's go to the next question. Put your eyes, the complete eyes on the next question.
Find the smallest number by which 295 must be divided to obtain a perfect square. Also find the square root of the perfect square so obtained. To the factorization number will come divided by the number.
Put your hand there in the question.
Find the smallest number by
Yasir, right hand only. Now this time we have to divide. For example, somebody tells you 252 is not a perfect square number. By what number it should be multiplied? Should be divided to get a perfect square number. Definitely you have to remove the 7 from the picture. Because this is the pair, this is the pair, but this is not a pair. You have to remove the 7. Whatever the work you do, same thing you have to do in the LHS. So actually we don't have the problem with this one. We have the problem with this one. We are dealing with the number. We are not dealing with the prime factorization. Actually, prime factorization is helping us to what should be done or what should you do. We have the problem with the number, right? Actually, number should be divided. This should not be divided. But actually, this is a root equation of the equality. Okay, that's why we are dealing with this one. But actually, now we have to write the 7 here. Okay, 7 here. Now, we have the problem here. Get your point? This question you will do by yourself. Let's go. Put it in there. Quickly. Hmm. Actually, he asked a great question. Now he's saying that, sir, the question is saying that you are telling me by what number, your question, I'm just quoting your question. You are saying that by what number it should be divided to get a perfect square number, right? The question is saying itself, I am the perfect square number. So why you're telling me? First thing. Second thing, your answer could be divided by 1. By what number should be divided, even if you want to give the answer, and the option is there in the option, multiple choice question is there, and option 1 is given there. By what number? So how can you say that by what number it should be divided or multiplied to get a perfect square number when already 36 is a perfect square number? But if it is a multiple choice question, it is your question what I'm talking about, or don't change your conversation. It is your question what I'm talking about. यही शख्सियत परस्ती ना मुझे पसंद नहीं आती. चेंज कर देना अपनी बातें. तू कुछ और पूछ रहा था, मैं कुछ और बोल रहा हूँ. यही जो तो directly say that no sir, you what were you saying that I'm not saying that. Speak. That's a great thing. Yeah, this is now the symbol of intellectuality. Let's go. Yeah. Of course you will get a perfect square number. So when you are getting a perfect square number, so how can you say that to make a 36 as a perfect square number to by multiplying something or by dividing something? How can you say that? Because already it is a perfect square number. Get that point? If the multiple choice question not there now, then no, directly we can say 36 is already a perfect square number. What should I say? Because if I remove the 3 and the 3 from the picture, again I'll get the 2 and the 2. If I remove the 2 and the 2, because somebody can cancel the 2 and the 2, 3 and the 3 will be there. If we remove the 3 and the 3, 2 and the 2 will be there. So what is the answer? 4 is the answer or 9 is the answer? What is the answer then? Somebody can say that. And if you remove all the things from the picture, you will get 1. And even 1 is a perfect square number. If you remove the 2 into 2 into 3 into 3, all things will be cancelled out and you will get 1. And 1 even is a perfect square number. The 3 possibilities are there. 1, 4 and 9. Get that point? So the question is saying that, very good question. Put your hand there. Very beautiful question is that. Question is talking about the rows, ROWS, and plants. Any more thing? Column is also mentioned there. Let's understand now something. Understand here something. What did you say? No, no, garden. I'm talking about the rows. Talking about or the column is also mentioned there in the question. No. Let's understand with a simple example first of all. Okay. Now try to understand that. For example, somebody tells you, or somebody we are dealing with now. Understanding. For example, you have 16 plants. How many plants? Total number of plants 16 here, right? Let's assume for a moment. Okay. Yeah. And somebody tells you in each row. Now, do you know that this is called a row? This is called a row. This is called a row. Okay, and this is called a column. This is called. Now, if you see one plant, second plant, third plant, fourth plant, first plant, second plant, third plant, fourth plant, first plant, second plant, fourth, third plant, fourth plant, first plant, second plant, third plant, fourth plant. Now, the 16 plants can be arranged or can be planted. You can see there in the row. Now try to understand here something. Let's remove this one, otherwise you'll be confused. How many rows are there? How many plants are there in each row? Four plants are there. To understand the game, what I'm telling you now, you will say so. Total number rows are there, 4, and total plants in. Did you sleep in the yesterday night? Did you sleep in the yesterday night or not? You slept with that? Then don't do that. If you are just feeling, do like this. Don't do that. I'm telling you, you cannot do that. अगले बार खाने के लिए तैयार हो जाना. When you are feeling, do like this. Directly. What I'm telling you now, you will say total number of plants, total number of in each row is equal to the number of rows. What somebody can say that? So 1 second. We can say that something here. Total number of rows multiply plants in each row equal to the total number of plants. What does it mean that? Total number of rows, how many? Plants in each row. Sir, 4? 4 ja? 16. Already total number of plants is given. Let us on the first thing here. Second thing. Now in this time, if you notice that question is saying that the number of plants in each row as much. Read out the question, second part of the question.
Such a way that each row contains as many plants as rows.
Question is saying that in each row, speak, such a way that, speak, second part of the question, in such a way that, one second. In each row contains as many plants
As the number of
in each row contains as many plants as the number of rows. Let me tell you what I'm saying now. In each row contains as many plants as the number of. It means 4 rows are there. It means in each row the 4 plants must be there. Do you feel what I'm saying now? 1 second. Well, let me tell you what I'm saying now. In each row 4 plants are there. The number of rows must be 4. According to this question I'm talking about. According to this question. Question is saying that in each row, as many plants are there in each row as the number of rows. Let me tell you. According to this question, what we can do, for example, 1, 2, 3, 4, 5, right? Now, how many rows are there? 5. So according to this question, in each row, just tell me how many plants I'll plant. So definitely I'll plant 5 rows. 5 plant. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? The question is saying that in such a way that these plants are planted in such a way that in each row as many plants are there as the number of rows. Get my point? Let's assume I don't know how many plants are there in each row. I will assume as in each plant, in each rows, or also we can say that number of rows equal to x. So definitely I have to say that number of plants in, you tell me, each row equal to x. I have to say that. What is saying? I'm not talking about the number of plants in all the rows. I'm talking about in each. The word I have used, we have used each. Do you feel something what I'm saying now? You don't understand now? Game? Let me just write one more time. What I'm saying to you now. I'm just telling you, or what we are talking here, just try to understand the game. Question is saying that, let the number of rows be x. Now the question is saying that these plants are planted in a such a way that in each row, read out the question now. Yeah.
In such a way that each row has a number of
Each row contains as many plants as the number of each rows contains as many plants. It means how many plants are there in each row? We will say 4 plants are there in each row, and total number of rows 1, 2, 3, 4. 4 are there. It means I can say that I'm not saying that how many plants are there in all the rows. Question saying about each, very important. The word each is very important. The word is there each now. That's very important. That's the game of the question. That's the game of the question. Question is saying that in each row, let the total number of rows be x. So you will say, sir, the total plants in, you tell me, each row, you tell me, b will be x, because question says the total number of rows x and total number of plants in each row x. Now just I told you, to get a total number of plants, total number of rows multiply plants in each row, total number of rows multiply plants in each row equal to the number is there 1225. X into x equal to 225. I hope you understood a little bit. No understanding now? I know no one understand. I know. Now what is the question asking? Last part of the question.
Find the number of
If I'll get the value of the x, then I can say the number of plants in each row. Let's do x into x. You tell me. So x equal to, tell me guys, 35 into 35. X equal to, you tell me, how many plants are there in each row? Do you understand that? Now also you can understand. Here. Total number of plants in each row multiply the total number of rows, because this is total number of rows we have taken as x, total number of rows we have taken x, and value of the x is plants in each row, because this is the value of the plants also in each row, value of the x. So here we got 35. You tell me, 35. You can see there. Do you understand that? So what is the difference between 35 and 35? Try to understand that. There are two different meanings in 35 and 35. This meaning has another meaning, this has another meaning. 35 telling the two different things. What is telling? It's telling that it means try to understand the game. The question, try to understand the game of the. I'm not going to solve this question. You will solve the. Now put your eyes there for the 5 seconds. Don't remove the hand. I have written the thing. You will just write as it is and you will solve the question. Put your eyes 5 seconds. 1, 2. Don't move it. Hey. 1, 2, 3, 4, 5, 6, 7, 8.